As you finish listening to your favorite composed disc CD, the CD its player slow down to stop. Assumes that the CD spins down with a constant angular acceleration. As the CD rotates clockwards at 500 RPM while the last song is playing, then it speeds down to a zero angular speed in 2.60 seconds with a constant angular acceleration. What is A? The magnitude of the angular acceleration of CD as it spins to the stop. So, looking at this, we're going to use constant angular acceleration motion, which the formula will be W final equals W initial plus AT, and we're looking for acceleration. So we'll isolate A by itself, leaving us WF times WI divided by T. And to do that, we'll label the numbers what we got here. So W final will be 500 RPM, considering that's the total amount of the rotating clockwards from the last song, RPM, and the time will be 2.60 seconds. But we're not done here yet. A one resolution equals 2 pi radians, and the units will be radians over second square, and 1 minute will be 60 seconds. So we will use the seconds for 60 seconds, because this is talking about seconds, to equal second square, and then we're looking for radians, and 2 pi will represent radians, and that will represent for W initial. So we will get ourselves 500 times 2 pi over 2.60 seconds times 60 seconds by itself equals, give us 20.14 radians second square, and that's our acceleration, 20.14. Going down to our second question, how many resolution does the CD make as it spins to a stop? So it sounds like to me that we will use our angular displacement, but to do that we will use our previous question, the number that we have. We got ourselves WF. WF is 20.14. Well, actually no, not 20. WF will be 0, since that we do have our final. And again, we're using angular displacements. This will be WF, W final square, equals W initial square plus 2A times theta. WF, W final will equal 0, considering that we have no final. We're looking for how many resolution does the CD make as it stops. So we set it as 0. This will give us, and again, we're looking for theta. So we will isolate theta by itself. So theta equals negative W initial square divided by negative 2A, 2 acceleration. So if we put that in our formula, we'll get ourselves negative. Oh yeah, we're not. Almost forgot. Considering that we don't have our initial, because our initial would be 2 pi is radians, and this is not what we're looking for because we just like put that in our segment. We're looking for how many resolution does the CD make as it spins. To do that, to find WI, or to get our new initial, is by setting this. So from our previous question, we got 500 RPM, we got 2 pi, and we got 60 seconds. We keep the 500, but we times the 2 pi and we divide by 60. Since the time from the previous question is irrelevant, so 500 times 2 pi over 60 seconds going to give us 52.36 radians over seconds. Over seconds. So now we're going back to our formula. The negative wi square divided by negative 2a will be negative 52.36 square divided by negative 2a. It will be acceleration, which would be 20.14. 20.14. So, 2 times 20.14. This will give us 68.06 radians. And remember, one resolution give us 2 pi radians, and 1 radians will give us 1 over 2 pi resolution. And to do that, we got 68 radians. So what we do here is we use 1.2 pi and time by 68.06. So 68.06 times by 1 over 2 pi going to give us, let's see here, 60.06 times 1 over 2 pi will give us 10.8 equals 10.8 over resolution. And that's how we solve for the first question and the second question.